All right, hi guys. Today we're going to talk about clouds and cloud formation. This was a lesson that actually is directly related to humidity, and it kind of blends into our next few topics that we'll be getting into later in the week. So let's start off with this presentation. This is online. You can find it under the class documents for Unit 7. These are the notes on cloud formation and types. This is a really short lesson, and I just want to quickly talk about how clouds form. So let's start with what is a cloud. A cloud is a mass of water droplets and ice crystals or ice crystals that are suspended in the air. Now, when you think about a cloud, a lot of people think that a cloud is it's water, but it's in its gas form. You wouldn't be able to see it if it was in its gas form. So it's not a vapor. It's actually liquid or ice crystals. Now, why are they staying up there? Because obviously water droplets are heavier than air or have a higher density than air, they would fall. So why don't they fall? They remain suspended because of updrafts of the air. The air pushes upward and keeps them suspended in the air. And because they're so tiny, they can float in midair, basically. Now, as they get heavier, they will start to fall out, and that's obviously what we call precipitation. But they remain suspended until they get big enough, and then they start to fall out. Okay, so again, a cloud is a visible mass because it's actually liquid water droplets or ice crystals. Okay, now, how in the world do you make a cloud? Well, obviously you need water. So the number one thing is you need water to go up into the atmosphere. It needs to evaporate off of the surface, go up into the atmosphere, and then it needs to cool down. So we need to change it from a gas, a vapor, back to a liquid again. And so what air is going to do, as it rises, the air cools off and it dips below what's called the dew point. And remember, at the dew point, the air is completely saturated. And so water changes from a gas to a liquid, and we call that condensation. So remember, clouds, cooling, condensation. Okay, you need to cool it off in some way. Now, the other crazy thing about water is that water droplets will not form, they will not condense unless they have something to cling onto. And in the air, there's no surfaces to cling onto. At least you wouldn't think there are. Like on the ground, it might cling on to the grass. In midair, there's like nothing there. So you're saying, well, what in the heck are they going to cling onto? Well, there's all this tiny little suspended particles that are in the air. Little tiny solids, microscopic stuff. Okay, dust, pollen. There's a lot up there. And it's suspended in the air. And it condenses onto that stuff. Now, a good example of this is if you ever watch an airplane, or you look at an airplane going through the sky, and you see a cloud behind it. Those are the particulates that are coming out of the engine, and the water that's in the air clings onto those particulates. Okay, so condensation nuclei are the last ingredient necessary. You need something in the air that's suspended up there that water can cling onto. And that's what this video right here is all about. And I'm going to
Somewhere inside of every raindrop is a tiny impurity, a touch of salt, a speck of soot, a grain of clay that's absolutely crucial to the raindrop's existence. In fact, without these microscopic pieces of dirt, there would be no rain, because water vapor can't condense into droplets on its own. Which is kind of weird, because water molecules like each other. If they didn't, they wouldn't cling to each other like this. And in the air, vaporized water molecules collide and stick together all the time, but they also break apart all the time, thanks to bond-breaking heat energy. Only when the air cools down past a certain point, called the dew point, does this breaking apart slow down enough for little clusters of water molecules to grow into droplets. But actually, that's only true if the cluster is big to start with. If it's too small, its surface is so curved that the molecules on the outside have few neighbors to bond to, which makes them easy to break off. So the cluster as a whole has higher chances of losing molecules than gaining them, even below dew point. Which means that up until a certain critical size, a cluster's chances of shrinking are better than its odds of growing. Unfortunately, that critical size is 150 million molecules. And while there are millions of 5-molecule clusters in a golf ball-sized volume of air at dew point, odds are that only one of those clusters will grow to a size of 10. And you'd need a golf ball of air 10 million miles across to find a single 50-molecule cluster, which basically means that clusters of water molecules never get to that 150 million mark on their own. Fortunately, they don't have to. They can start off at that critical size by condensing onto one of the gajillions of little pieces of dirt floating in our atmosphere, and then grow and grow until they're a droplet in a rain cloud. And ultimately, it's these little pieces of dirt surrounded by water that make life possible on our big piece of dirt surrounded by water.
Now, in order to get the air to cool off, so this is going back to this idea right here. We covered condensation nuclei in that video, but you need to cool off the air. And how do you cool off the air? Well, the best way to do it and the most common way to do it is to just lift air to a higher altitude. As you rise up in what's called the troposphere, the lowest layer of our atmosphere, as you rise up through that, air cools down, okay? And so you just need to lift the air somehow. Now, the most common way to do that is through a weather front. And we're going to be talking about fronts later on, and we'll talk about how these clouds form on a front. But you're lifting the air up to a higher altitude because the denser air sinks, the less dense air rises. Okay, so warm air is less dense, it rises up. Okay, so the most common way to do that is in a front, in a cold front or a warm front. Another way to make clouds is to push them up and over higher terrain. So in mountain ranges, okay, you're going to see a lot of cloud formation above the mountain. And that's because air is cooling down as it rises. Okay. Another way to cool down or to make air cool down is just to mix it. And that is really common on a winter day when you go outside. The hot air that's in your lungs, as it goes out into the atmosphere, as you breathe out, you're mixing warm air with cold air, and that water vapor that's in your lungs condenses really quickly, and so you form a cloud in front of you. Okay, and you can do demonstrations with that, and maybe I'll try to find some for you. Okay, but the most common, I would say, is this convergence idea of lifting. All right, this picture I just wanted to show you. These are just jet trails, okay, contrails that are coming out of the back of the engines of the jets that are flying through the atmosphere. As they fly through colder air, the particulates that come out of the engine, the exhaust, right, is going to allow the water to cling onto it. And because it's already cold, it leaves a trail behind it. Okay, already did that. All right, now, just a little heads up about condensation nuclei. You got a little idea about that in the previous video. Condensation nuclei can come from a lot of different sources. Dust from the surface, fires like smoke, the exhaust from automobiles or planes or factories or whatever. Volcanic eruptions put a lot of ash into the atmosphere. And then there's plant pollen that can go up into the atmosphere as well. So there's all these different sources of condensation nuclei that are natural and man-made. A condensation nuclei is tiny, it's microscopic. The size of it compared to a typical raindrop, you can't even tell, but it's this tiny little thing inside of a normal raindrop. So just to kind of look at the comparison there. Okay. This video is all about how clouds were named, and I'm going to give you guys the information about this, and I'll give you a separate link to this video later. All right, so let me just go back quickly to this. How do you get from this typical cloud droplet? Like this would form around a condensation nuclei, right? You have this water droplet. The water droplet is condensing around this nucleus. And then this is suspended in the air. And then it gets bigger and bigger and bigger. Essentially, it's like a mosh pit. Like you have all these, you guys don't know what that is, but a mosh pit is like this crazy thing they did back in the 90s where they would go to a concert and a bunch of guys would just like run into each other during the concert and like smash into each other. I don't know why. It was a weird phase. Don't ask. You can look it up later. Water droplets in a cloud are colliding with each other. They're mixing with each other. And as they collide, they like stick to each other. If you ever play that game like Blob Tag in elementary school, it's kind of like that, where they collide and they cling onto each other. They stick to each other. Water is a sticky molecule. And so as they collide and stick to each other, they just get bigger and bigger and bigger and bigger until they form drizzle droplets, which are shown up here. Okay. And those might get bigger if you mix them even more. If you have a lot of lift from a front, they'll get bigger and bigger. and you get these bigger rain droplets that will then be so heavy that the air can't hold them up anymore and they fall out. Okay, so just a heads up, that's how these droplets get bigger and bigger over time. All right, so going back to this, we classify clouds according to these three categories: their height above the ground, so their altitude, their appearance, and how vertically developed they are. And so there's like three layers of clouds. We have low clouds, which are just above the surface, 6,500 feet or below. Middle clouds, 7,000 to 23,000 feet. And then high clouds, which are like up where you fly an airplane. Okay. And then there's vertically developed clouds, which are down here. And you can pause the video and look at all these names and might recall some of these names. Vertically developed clouds are called cumulus clouds. Rain-bearing clouds, the ones that are really dark on the bottom, those are called nimbus. They have a prefix of or a suffix of nimbus or nimbo. Okay, so that guy in this video is the one that came up with these names, and you can watch that video separately. Now, some other translations. There's a lot of Latin in the classification of clouds. There's the prefix cirro, which means like a curl of hair. It kind of looks like baby hair. It's kind of wispy and curly. Okay, those are cirro clouds or cirrus. They are often curly or like wispy because they're at a higher altitude. And the higher the altitude, the more drawn out and stretched out they are because of the high winds up there. Alto, and if you know anything about like music, alto is in middle range. Okay, so alto means middle layer, so somewhere above 7,000 feet. Strato means low. Okay, so a very low cloud or a layer of cloud as well. Stratus means a layer of cloud, almost like blankets the whole sky. Cumulo means heap, kind of looks like cotton balls. Okay, and as I said earlier, nimbo means rain-bearing, precipitation definitely happening. Okay, so those are some translations for you. And you can see all these things in this image right here, which is a really good one. So you can see all the prefixes and suffixes. Let's start down low. Stratus, strato, meaning low to the ground. Stratocumulus, so you add them together, you get this layer of clouds that's low, but they're kind of cumulus, puffy, look like cotton balls. Stratus is covering the whole sky. Cumulus, again, vertically developed, puffy looking. All right. Cumulonimbus, really tall. This is our big thunderstorm kind of cloud. They start real low, rain-bearing, right, and then rise up to really high altitudes. Okay, this would happen with a cold front. Alto, now we're in the middle. Alto meaning above 6,000 feet, up to 20,000 feet. Alto cumulus, puffy. Alto stratus covers the sky. Cirrus, cirrus meaning wispy, hair-like, okay? And then cirrocumulus, the puff balls at a really high altitude. Okay, so those are the different types of clouds in our troposphere. And there's a lot more than that, but those are the basic ones. And here's another image that shows some of those things. If you want to pause and look at that image as well, you can. Okay, so a little quiz time. What in the world is that cloud right there? If you saw that on a nice day, you're looking outside and you're like, oh, those are really wispy clouds. These are really high altitude. What are they called? And if you know, you can guess, but the answer is a cirrus cloud. Okay, see the wispiness, the hair-like. Okay, really at high altitude. Usually means that a warm front is coming as well. And we'll talk about that later on. All right, about this one. High altitude, not as wispy, more puff, like cotton ball-like. And the answer to that one is cirrocumulus. Okay, the puff balls, but high altitude. All right, what's that thing? It's covering the whole sky. You can see a ring around the sun. Sometimes you see a ring around the moon at night with these. These are called cirrostratus, so high altitude but covering the sky. Stratus meaning covers the sky. Okay, when stratus is at the end of the word, it's the layer, like it covers the sky. All right, these are a little bit lower altitude. You can kind of tell they're closer to you. These are called altocumulus. Okay, it's at a alto range, so around 7,000 feet or so, and cumulus meaning the shape of them. All right, again, this is not cumulus, it covers the sky, so that's the stratus, the layer. That's called altostratus. Okay, here's another one. That is like right on the ground. It's really low. You can see the water basically in front of you. It's like you're in the foggy conditions. This is just straight up stratus on the ground covering the sky. All right, these are low, puffy. What are they called? Those are called stratocumulus. Stratocumulus meaning low to the ground, but cumulus, they have that puffy look to them. These are happy weather clouds. Okay, nice day. All right, low to the ground. Look how dark they are underneath of them. This is called nimbostratus. Nimbo meaning rain bearing, the dark color, probably raining out of these. These can turn into some, rainy day kind of conditions, kind of like our weather yesterday when I was doing the lab for humidity. All right, this is a really happy cloud, right? Look at that. It looks like a hippo, maybe? I don't know. These are the kind of clouds that you can say they look like something. These are just called cumulus clouds. Happy, like summer day. All right. Now that one is a little bit scary looking, right? It looks like a nuclear bomb went off. It's not. It's a actual cloud that forms naturally. And you can see really, really, it's on the ground, but it stretches up to a really, really high altitude, really vertically developed, raining down here, stretching out at the top, and it spreads out at the top because the pressure is lower up here. And this is called, the scary one, the cumulonimbus. The cumulonimbus is the thunderstorm kind of cloud. When you see that, guaranteed thunderstorm in that area might be moving your way. It could be tornadoes too if it's out in the Midwest. Anyway, so those are our clouds. If you have any questions about anything, you'll never be asked on a Regents exam to name clouds, but you will be asked questions about how clouds form. And we'll be talking more about that in the future, but hopefully you guys get the idea of how they form. And don't hesitate to ask me questions. All right, thanks.